Welcome to this lecture on differentiability by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
Shivam. Good afternoon, Manish. So in the last class, we finished our continuity part, right? We discussed types of discontinuities. So now we will start with
Yes.
differentiability. Okay. What was the definition of differentiation or differentiability? Yes. When you say that a function is differentiable at a point A, yes, a function f from some interval AB to R is said to be differentiable at C belonging to AB. If yes, what was the definition? If when we say a function is differentiable at C, if limit x tends to C fx minus fc upon x minus c exists, right? If this limit exists, then we say that the function is differentiable at C belonging to AB, right? Yes, remember this definition? That is limit h tends to 0 fx plus h minus fc plus h minus fc upon h exists. Okay, this limit is equal to this limit. So if this limit exists, then we say that the function is differentiable. And when a limit exists, limit कब exist करता है? अभी हमने पढ़ा है. Yes. Limit x tends to a fx exists if and only if, yes, LHL at a is equal to RHL at a, right? If LHL is equal to
Yes,
RHL,
sir.
then this limit exists. So what about this? So this exists if it's LHL, and its LHL is called LHT. We call it as LHT. Okay, left hand derivative. F C minus h to fc upon minus h exists, and RHT is okay. If LHD exists, RHD exists, and they are equal, and LHT is equal to RHT. If these three things happen, then we say that the function is differentiable at C, right? That is, if LHD exists, RHD exists, and LHD is equal to RHD, then we say that the this function is differentiable at C, and the derivative at, and in that case f dash C is equal to limit x tends to C fx minus fc upon x minus c, which is equal to your common value of LHT and RHT. जो भी common value होती है, that is the derivative of the function at point C. Okay, is it fine, everyone? Is it clear?
Yes, sir.
Yes, sir.
पढ़ा हुआ है तुमने वैसे, ठीक है? So so this is the definition. Derivative of f. Okay, so this this formula should be defined like this, provided it exists. Provided limit exists, ठीक है? अगर limit नहीं exist करती, then we cannot say that the derivative. So इस तरह से ये जो है, this is when provided limit exists. Okay. So if this limit exists, then we say that the function is differentiable at x and the derivative is given by the value of the limit. Is it fine, everyone?
Yes, sir.
Okay. So let us do an example for this. Find the derivative of x with using limit formula. Using limit formula. Okay. So we will use the limit formula. Direct derivative nahi, we will use the limit formula to find this derivative. So let us start. Consider limit x tends to c fx my या पहले pick any arbitrary real number for any x belonging to R. Consider, so we will find this limit. Okay, we will use this limit h tends to 0 fx plus h minus fx upon h. So what will be this? This will be fx plus h is x plus h whole square minus x square by h. Now use the formula a square minus b square. So what it will be? X plus h plus x plus h minus x, right? A plus b, a minus b upon h. So this will be this. So x gets cancelled, h gets cancelled. So you will be left with 2x plus h, and now you can take the limit. So what, because x is independent of h, so this will become 2x plus limit h tends to 0 h, which is equal to 2x. So since this limit exists, so by definition of differentiability, we have f dash x is equal to 2x for all x belonging to R, right? Is it fine, everyone? Okay, f dash x is this limit. So first you find this limit. अगर ये limit exists करता है, then you say that the f dash x is equal to the value of the limit. Is it fine? Is it clear?
Yes, sir.
So another question. So again we have to use the limit formula only. अभी जो है हम सारे questions limit से करेंगे, बाद में direct formula से करेंगे. Using limit formula. So how to proceed? Yes. So for any x belonging to R, consider, what we will consider? Limit h tends to 0 fx plus h minus fx by h. So this is limit h tends to 0 x plus h cube minus x plus h minus x cube minus x upon h. So what will be this? So q वाले terms एक साथ कर लो और ये वाले terms एक साथ कर लो. So then you will be left with x plus h cube minus x cube plus, बल्कि minus common निकाल लो. So you will be left with x plus h minus x upon h. Fine. Now what is the formula for a cube minus b cube? Yes.
A cube plus b cube plus 3a square b plus 3ab square.
A cube minus b cube is a minus b
a square
a
plus b
square
square.
plus
plus
ab.
ठीक है. So this is the formula. Just keep So this will become x plus h minus x, which is equal to h x plus h whole square plus x square plus x plus h minus h, right? Is it fine? So now when you will take h common and you will have this h is there in the denominator, so it will get cancelled out. So you will be left with, if you will simplify it further, so you will be left with x plus h whole square plus x square plus x square plus xh, right? Now take the limit. Now you can take the limit because it is a polynomial, so you can take the limit inside. So this will become 0, this will become 0. So you will be left with x square plus x square plus x square, which is equal to 3x square, right? Yes. -1 छूट गया यहाँ पे, ये -1 भी आएगा साथ में. So this -1 has to be there. So -1. So 3x square -1, right? So by definition of derivative f dash x is equal to 3x square minus 1 for all x belonging to R, right? Here everyone. So let us do one more question of this type. So find the derivative with respect to x using limit formula. ठीक है? So solution. Yes, how to start? So we will start with for any. अब ये देखो, ये कहाँ पे इसका एक तो f का डोमेन कहाँ पे है? डोमेन जो है वो ग्रेटर देन 0 पे है. So we will take x greater than equal to, for any x greater than equal to 0, consider limit h tends to 0 fx plus h minus fx by h. So this will be limit h tends to 0 root x plus h minus, yes, root x by h. What next? What should we do next?
सर रेशनलाइज कर देंगे सर.
Yes, we will rationalize it. क्योंकि अभी तो ऊपर फॉर्मूला लगा नहीं सकते. So what we will do is we will rationalize it. So we will multiply and divide by root x plus h plus root x by, so this will become ये जो a minus b, a plus b, so it will become x plus h minus x right. So now h and h will cancel out. You will be left with one by 2 root x plus h. So now you can take the limit. So this you will get x, right? So by definition, अब ये कहाँ defined है? For which values of x this is defined? This is defined for all values of x which is positive, right? So इसलिए हम by definition, so यहाँ पे देखो ये जो था, this limit exists for every real number. So इसलिए हम यहाँ पे for all x belonging to R कर रहे थे. यहाँ पे भी if you see, this limit exists for every real number. So that's why we are writing it x belonging to R. But this limit is defined only when your x is positive, right? Because x is positive and x is greater than 0. 0 पे defined नहीं है, right? This is defined only when, so defined only if x is strictly greater than 0. So our domain will be, so by definition of derivative, yes, what will be domain? F dash x is equal to 1 by 2 root x for all x greater than 0. Okay, is it fine? सो जीरो भी इंक्लूड नहीं कर रहे क्योंकि जीरो पे डिफाइंड नहीं है. इज इट फाइन एवरीवन? सो इसका डोमेन जो है डेरिवेटिव का डोमेन, यहां से पता चलेगा कि लिमिट कौन से वैल्यूज के लिए एग्जिस्ट कर रही है. जिन वैल्यूज के लिए एग्जिस्ट करेगी वही हमारा डोमेन होगा डेरिवेटिव का. फाइन. यस, इज इट क्लियर?
Yes, sir.
Okay. So what does derivative in general represent? अभी हमने करा. So derivative is limit of fx minus fc upon x minus c. Right? This is the derivative. Now what does this is representing? This is represent change in f, right? Change in f with respect to change in this values of x, right? So in general, what does our derivative represent? It represents the rate of change of derivative. So for example, if at time, so if you have a function with time, okay. For example, if you have a function with time, okay, and this is time t, okay, and this is something depending on time, some function of time, okay. फंक्शन ऑफ टाइम, कोई एग्जांपल बताओ फंक्शन ऑफ टाइम जो टाइम पे डिपेंड करता हो कुछ ऐसा. ठीक है, सपोज दिस इज योर फंक्शन f with respect to time. So what is this is, if this is your a, so this is your, suppose this is your c, so what does it represents? So this is your c, so what does it basically representing? This limit t tends to c fx minus ft minus fc upon t minus c. So basically you are checking the change in this with respect to change in time, right? You're calculating the, and when this limit is tending to 0, so what is basically you are finding is this is rate of change in f, right? टाइम के साथ कोई भी चेंज होती है तो उसे रेट ऑफ चेंज इन एफ बोल देते हैं, राइट? यस. तो कौन कौन सी ऐसी चीज होती है, कोई फंक्शन, कोई एग्जांपल बताओ जो रेट जो डिपेंड करती है टाइम पे.
Displacement, sir.
Yes, distance. कोई if you are having some vehicle or something which is moving, so its distance depends on time, right? At time t, suppose distance at time t is given by dt, then what will be your rate of change in distance? Rate of change of distance क्या होता है? What does this represent?
Speed, sir.
Speed, velocity. क्योंकि डायरेक्शन भी होती है ना इसमें, so it is called velocity. ठीक है, so vt is nothing but rate of change of, so you will calculate this. ठीक है, so this is nothing but limit t tends to 0 dt plus h, yeah, h tends to 0 dt plus h minus dt upon h. ठीक है, so this is the formula for velocity. Change in distance upon change in time, right? Speed is change in distance upon change in time, distance upon time basically. ठीक है, लेकिन वो जीरो जो हमारा इनिशियल पॉइंट होता है उससे लेते हैं हम. स्पीड को कैलकुलेट करने के लिए क्या लेते हैं हम? डिस्टेंस ट्रेवल्ड अपॉन टाइम टेकन. ठीक है, सो अगर at time t naught it is this, so it is basically dt minus dt naught upon t minus t naught, right? This is the time taken, this is the distance traveled. ठीक है, और फिर जब इस पे लिमिट लगा दोगे तो यू विल गेट द रेट ऑफ चेंज. ठीक है, Is it fine? So that is called instantaneous velocity of a particle. इंस्टेंटेनियस वेलोसिटी जो अगर लिमिट लगा दोगे अब t naught tends to और t tends to t naught, that means you are calculating the instantaneous velocity, मतलब उसी मोमेंट की वेलोसिटी. ये तो स्पीड हो गई when you are taking the time from t naught to t, बट जब लिमिट ले जाओगे t to t naught, then you will find the instantaneous velocity कि बिल्कुल उसी मोमेंट पे क्या वेलोसिटी होगी. ठीक है, this is the formula. So it for so if t replacing t naught, so if s is the function of t, that is s is representing the position of the particle. Okay, ft represents the position of the particle, then the instantaneous velocity at any arbitrary time t is given by this limit h tends to 0 ft plus h. So that is instantaneous velocity. Okay, so because ft is representing the position function, so vt is equal to f dash t. Okay, so instantaneous velocity is the derivative of the position function. ठीक है, कि किस टाइम पे क्या पोजीशन है वो फंक्शन को डिफरेंशिएट करोगे तो यू विल गेट द वेलोसिटी. ठीक है, और डिफरेंशिएट करना है टाइम के रेस्पेक्ट में. इज क्लियर? यस, इज इट क्लियर?
Yes, sir.
सो इस तरह के क्वेश्चंस अगर so let us see question, then you will understand it much better. So now you are given a function, so you are given a position function s equal to ft and its position is given. So at time t equal to 0 it is at distance 1, at time t equal to 1, so जो भी put values put करते रहोगे you will get some position of the particle. Some particle is moving and you are getting, so some particle is moving like this arbitrary. ठीक है, किसी तरह से move कर रहा है and this is your time. So at time t naught it is here, then at time t it is here. So इस तरह से time change करते रहोगे तो position change कर रहे हो, right? So this is your position function. ठीक है, so this is the position function. You have to find the velocity of the function of the particle. Okay, so we know that velocity of the function, velocity function of the particle vt is given by f dash t, right? It is f dash t, which is equal to limit h tends to 0 ft plus h minus ft upon h. So let us find this limit. So 1 plus 5t plus h minus 2t plus h square minus 1 plus 5t minus 2t square by h. So आप क्या करोगे, सेम ऑर्डर वाले टर्म्स को एक साथ ले लोगे. So 1 and 1 will get cancelled, or 5t plus h minus t minus 2t plus h square minus t square. So what you will get, ये तो h हो जाएगा 5h minus ये t plus h whole square. So a plus b, a minus b. So जब माइनस करोगे तो बस you will be left with h. So 2t plus h, right, on simplification. So then when you will take h common and then you will cancel out it with denominator, so you will be left with 5 minus 2t plus h, right? So when you will take the limit, you will get 5 minus 4t. Okay, is it fine?
Yes, sir.
Okay. So ये तो हो गया कैलकुलेशन पार्ट. अब थोड़ा थियोरेटिकल पार्ट करते हैं. ठीक है, so let us come back to the definition of differentiability again. Okay. Back to it. go through the definition once. So a function f is said to be differentiable at x0. So if the limit this exists, so if this limit exists, then we say that the function is differentiable and the derivative is given by f dash x0. If f is differentiable at each point of the open interval ab, then we say that the function is differentiable on ab. ठीक है, अगर हर एक पॉइंट पे डिफरेंशिएबल होता है तभी हम कहते हैं कि उस सेट पे डिफरेंशिएबल है. तो अगर हमें एक प्रूव करना है कि किसी सेट पे डिफरेंशिएबल है, तो व्हाट वी विल डू, we will take any arbitrary point of that set and we will try to prove that the function is differentiable at that point. And similarly, same thing happens for our unbounded interval. So a plus infinity या minus infinity to b या minus infinity to plus infinity. So in that case, अगर ये वाला केस होता है, मतलब कि पूरे r पे ही डिफरेंशिएबल हो गया, क्योंकि this is nothing but your set of real numbers. So then we say that the function is differentiable everywhere. ठीक है? Yes, is it clear? Okay. So geometrical interpretation is geometrically what does it represents? Let us see. Okay. Let us see what it generally represents in geometrically. Okay, suppose you have a function. This is your a, this is your b, and this is your x0. So this point is, what is this point? This is your function f. So what does this point? Yes, what is this point? x0, fx0, right? Yes. And let us take any point. So ये point right पे भी हो सकता है, left पे भी हो सकता है. This is just representing a point. So this is your point. ठीक है, या तो कर्व को थोड़ा ज्यादा घुमाते हैं so that फिगर अच्छी सी बनेगी अपनी. ठीक है, we can have a very good figure for this. So let us just represent it like this. Okay, I want to have sharp turn. Yes. Okay. So let us take the point at this side, x here. This is your point x0, fx0. Okay, and this will be your point x, fx. Okay, let us join these 2 points by this line. Yes. Now what is the slope of this line? Yes, what is the slope of this line? So what will be slope of this line? Slope of the line joining the points x0, fx0 and xfx. What is the slope of this line? Yes, बताओ जल्दी. Yes, slope of the line joining the 2 points. What is that? y2 minus y1 upon x2 minus x1, right? Yes. So slope of this line. Now if I take the limit x tends to x0 m, what will be this? This will be, ठीक है, I am, see, geometrically हम देख रहे हैं कि right side में point है, but this point can be anywhere from left to right. अभी अगर मैं limit, if I take x to x0, what will happen to this line? This is a chord. Chord क्या बन जाता है जब हम उस point पे पहुंच जाते हैं? Yes, chord क्या बन जाता है? If we take x to x0, then the line joining the points x क्योंकि ये लाइन जो है बेसिकली दिस लाइन इज बिगर लाइन, सपोज line passing through 2 points, ठीक है. If I take this line passing through 2 points, then if I take x to x naught, then what will this become? Joining मत करो, passing कर दो, then you will understand it better. अब बताओ. Passing through the points. Yes. अब बताओ. The line passing through the points becomes what? What does it become? Yes. What does it become? बताओ जल्दी. अगर ये x to x naught हो जाएगा, ये दोनों पॉइंट्स एक ही जगह हो जाएंगे, तो क्या लाइन बन जाएगी ये? It will become this sort of line. Yes. क्योंकि अब तो बस दोनों पॉइंट ही सेम हो गए, तो बस यही पे है. तो what does it has become?
Tangent.
Tangent. Yes. The line becomes the tangent. ठीक है. So if we take x to x naught, then the line passing through the points x of x, x naught f x becomes a tangent. Becomes tangent to f at x naught, right? Tangent at x naught. So this, because this was the slope of the line passing through these 2 points, so what will this be? So this becomes slope of the tangent to f at x naught, provided this limit exists. Provided this limit exists, right? So if this limit exists, then this becomes slope of the tangent to f at x naught. So basically, geometrically, a function f is differentiable at a point x naught if the function, if the graph of if the graph of the function has a tangent at x naught. ठीक है. So function is differentiable at point x naught provided the graph of the function has a tangent at x naught. That is, and moreover, the slope of the tangent to f at x naught is given by f dash x naught. ठीक है. This is equal to limit x tends to x naught fx minus fx naught upon x minus x naught. Is it fine everyone? ये पढ़ा भी होगा ना, किसी भी अगर हमें फंक्शन का स्लोप निकालना होता था तो हम dy by dx निकाल लेते थे. रिमेंबर? टेंजेंट एंड नॉर्मल्स में जो करते थे, dy by dx represents the slope of the tangent, right? Remember? And इसका वो 1 by minus 1 by dy by dx slope of normal, ये फॉर्मूला यूज करते थे ना. So this is derivative of the function. ठीक है. So ये इसी से ही आता है, ये geometrical interpretation से ही आता है. ठीक है. Is it fine everyone? So geometrically, if the function has a tangent at some point, then you can say that the function is differentiable at that point, and the slope of the tangent to f at x naught is the value of the derivative at that point. Is it clear? Yes. Now let us see some situations. Okay, let us see some situations. Let me take some function. consider these two functions. ठीक है, ये क्या हो रहा है इसमें, ये x नॉट है, यहाँ पे ये is the function differentiable at x naught, is this function differentiable at x naught? Yes, is this function differentiable at x naught? ये फर्स्ट केस फिगर से ही देख के बताना है हमें। x नॉट अगर अभी ये हमने ज्योमेट्रिकली पढ़ा है ना, क्या होता है, फंक्शन इज डिफरेंशिएबल एट x नॉट इफ द ग्राफ ऑफ द फंक्शन हैज अ टेंजेंट एट x नॉट। डज इट हैव अ टेंजेंट एट x नॉट? देखो लेफ्ट से क्या टेंजेंट आएगा, अगर तुम्हें एक टेंजेंट ये होगा तुम्हारा, ठीक है, एक टेंजेंट जो होगा वो ये होगा, यस यस, एंड अनदर टेंजेंट विल बी एट दिस, राइट। अगर लेफ्ट से देखें तो ये वाला टेंजेंट आएगा, राइट से देखें तो ये वाला टेंजेंट आएगा, सो देयर इज नो टेंजेंट, ठीक है, इस पॉइंट पे टेंजेंट नहीं है, ठीक है। लेफ्ट से ये वाला टेंजेंट आ रहा है, राइट से ये वाला टेंजेंट आ रहा है, लेफ्ट से ये वाला टेंजेंट लेफ्ट से इसको कट कर रहा है, ये वाला टेंजेंट इससे कट कर रहा है, ठीक है। सो अगर ऐसा शार्प टर्न आता है कहीं पे, देयर इज अ शार्प टर्न, इसे शार्प टर्न कहते हैं, सो फंक्शन विल नॉट बी डिफरेंशिएबल एट दैट पॉइंट, ठीक है। ऐसा कोई एग्जांपल बताओ सिंपलेस्ट जो हम पढ़ते हैं शार्प टर्न वाला।
सर मॉडुलस फंक्शन।
यस, मॉडुलस फंक्शन, व्हाट हैपेंस इन दैट, वो जीरो पे क्या हो जाता है, शार्प टर्न हो जाता है उसमें, ठीक है। इफ यू लुक एट दिस फंक्शन, so graph of the modulus function is this and there is a sharp turn here, ठीक है। so it is differentiable at all the points except at the point 0, ठीक है, fx equal to mod x। so if you see this sharp turn, right, or corner point you can say, or you can say corner point, so at this point function is not differentiable, so at this point function is not differentiable because tangent does not exist at this point, okay, is it fine? so let us अब तो ज्योमेट्रिकली तो कर लिया, let us do some examples। so अभी बस mod x का करेंगे हम, you will show that mod x is not differentiable, ठीक है, बाकी हम नेक्स्ट क्लास में करेंगे, ठीक है। so mod x का ज्योमेट्रिकली तो हमने देख लिया है कि it is not differentiable at 0, right, it is differentiable at all other points but not differentiable at 0, right। this is the graph of the function, so geometrically we know because there is sharp turn, so it is not differentiable at this point, so let us do its quotient। so we will show that to show f is not differentiable at x equal to 0, so for this what we will do, we will find LHT and RHT। so LHT, limit h tends to 0, h greater than 0, f of right, f of 0 minus h will be mod minus h minus mod 0 upon minus h, so this will be h by minus h, which is equal to minus 1. now what about RHT? RHT will be limit h tends to 0, h greater than 0, f of 0 plus h minus f of 0 upon h, so which is equal to limit h tends to 0, h greater than 0, mod h minus mod 0 upon h, so this is equal to, because h is positive, so h by h. So LHD is not equal to RHD. So this implies f is not differentiable at x equal to 0. Is it fine? Is it fine?
Yes, sir.
बाकी अगर हमें शो करना हो, it is differentiable at all other points, so we can show it. ठीक है, चलो कर ही लेते हैं कि कहीं एग्जाम में आ गया कि show that it is differentiable at all other points. So to show fx equal to mod x is differentiable on r minus 0. ठीक है, 0 को हटा के सब पे डिफरेंशिएबल है, तो कैसे करेंगे? We will pick any arbitrary point, let C belonging to r minus 0 be any point. ठीक है, is it fine?
Yes, sir.
Okay, so अब हमारे पास दो पॉसिबिलिटी बचती हैं. केस 1 when C is positive. ठीक है, C is positive, then you can find the limit. So limit h tends to 0, f of c plus h minus fc upon h. So this will be limit h tends to 0, mod c plus h minus mod c upon h. Now because we are taking h to be tending to 0, so we can consider h to be very small, right? We can consider h to be very small. So here is our 0, here is our c which is greater than 0. So we can consider our h to be c plus. So c plus h इधर भी हो सकता है या c plus h इधर भी हो सकता है. So basically c plus h lies in this region. So if h is even negative also, because we are not considering h to be positive, हम दोनों लिमिट साथ में लेके चल रहे हैं. So even then this will be, ठीक है. So c plus h will lie between these two. इसमें लाई कर सकता है क्योंकि h is tending to 0. So this will, so c plus h will also be positive. So we can keep it like this. ठीक है. So c plus h is n for small h. ठीक है. It may be h may be negative, it may be positive, but we can take h arbitrary small so that c plus h is also comes out to be positive. So ये क्या हो गया? h by h which is equal to 1. ठीक है. So इसमें केस 1 में ही हो गया. अगर तुम चाहते हो तो LHD RHD अलग से निकाल के कर सकते हो, और what you can do is you can simply calculate this limit, because LHD RHD में भी तुम्हें LHD में तुम्हें c minus h को पॉजिटिव कंसीडर करना ही पड़ेगा, because you are taking h very small. ठीक है, is it fine? Is it fine?
Yes, sir.
Case 2, when c is negative, then you will show that. So in this, अच्छा ये एक चीज लिखते हैं. So by definition, so then f dash c is equal to 1. Case 2, c is negative, consider limit h tends to 0 fc plus h minus fc upon h. So limit h tends to 0. What will be this? अब क्या है? c नेगेटिव है तो c plus h will be treated as negative. ठीक है, जो c का साइन होता है वही c plus h का भी साइन होगा, क्योंकि h जो है हमारा बहुत स्मॉल है. अनलेस की c 0 है तो c plus h और c minus h का साइन चेंज होगा, अदरवाइज c plus h और c minus h हमारे सेम साइन के होंगे as that of c. So because c is negative, so c plus h will be treated as negative. So this will be minus of c plus h minus c, right, upon h. So this will be equal to minus h by h, which is, so f dash c is equal to minus 1. Hence f dash x is equal to 1 if x is greater than 0 and minus 1 if x is less than 0, and f is not differentiable ठीक है. So this is all about fx equal to mod x. Fine everyone? Is it fine?
Yes, sir.
Okay, so this much is enough for today. बाकी और क्वेश्चंस कल करेंगे, थोड़े और क्वेश्चंस इस डिफरेंशिएबिलिटी के ऊपर. And then we will go to successive differentiation. So any questions anyone want to ask? Yes, any questions?
No, sir.
Okay, so as there are no questions, I am ending this class. Bye everyone, have a good day.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.